Hello everyone, I'm myself Dr. Dipti Kariya. I'm MD PhD Physiology and your educator for Physiology. Today we'll discuss about waves, segments and intervals of ECG. Before starting my class, I would like to inform you all that you will get all my physiology notes in soft copy as well as hard copy. To get the soft copy, you have to download the application VESALIUS and you have to subscribe. And for hard copy, you can order my book that is Physiology Notes, available on Flipkart as well as Amazon. Link for both that is given in the description box. You can also join our WhatsApp group that is 78638 22668. This is the WhatsApp number. You can join through sending message, or you can also join me by the WhatsApp link that is also available in the description box. By this WhatsApp number, I can try to solve your queries. If you have any queries related to physiology or any other, you can send me message on the WhatsApp. I'll try to solve your queries as soon as possible. Okay. Now we'll discuss today's topic, that is electrocardiogram. We are continuing our topic of electrocardiogram. Today we'll discuss about various waves, segments and intervals of ECG. Okay. Now, what is ECG? It is the record of fluctuations in the potentials during cardiac cycle. During cardiac cycle, potential gets fluctuated and we will get wave of excitation that spreads from atria to interventricular septum, then ventricular wall, and this wave of excitation, which is known as depolarization, that is followed by repolarization. Okay, these waves commonly we are found on the in ECG. They are P wave, QRS, complex, T wave, and sometimes U wave. Okay, we will discuss one by one. Now, starting with P wave. What is this P wave? You can see here, this is first positive wave, and direction of the P wave, that is upward, and it is rounded. What is the cause of P wave? That is because of depolarization of atria. Atrial depolarization gives positive wave, that is P wave, atrial depolarization. Okay, what is the duration? Try to remember all these durations and amplitudes. Duration of P wave, that is about 0.1 second, and amplitude, that is about zero point 0.1 to 0.12 millivolt. Okay, what is the clinical significance of P wave? Amplitude of the P wave, that denotes functional activity of atrial muscle. Okay, now clinical or applied aspect. You can see here, this is P mitral. So in case of mitral stenosis, what happens? Because of stenosis of the mitral valve, left atrium gets hypertrophy, and because of hypertrophy of left atrium, P wave, that is large and prolonged. Okay, and another thing, that is tricuspid stenosis. When tricuspid valve gets stenosed, right atrium gets hypertrophied. So you have tall and peaked P wave. Here it is not prolonged, but it is peaked with normal duration. Duration is normal. It is not prolonged. Okay. Now, another applied aspect is in case of atrial fibrillation. You can see here, this is atrial fibrillation ECG. You will not get single P wave. You have fine irregular oscillations instead of single P wave. Okay. And in case of ectopic pacemaker, means pacemaker is other than SA node. Okay, you will be having altered or inverted P wave. Okay, so this is in case of ectopic pacemaker. You can see here, this is in case of ectopic pacemaker. Fine. Now, next is QRS complex. QRS complex, that consists of Q wave, R wave here, and S wave. Okay. Now, here you can say Q wave is small, S is also small, and a big R wave. Okay, S is negative, Q is also negative. And what is the cause of QRS complex? That is because of depolarization of ventricle. Ventricular depolarization, it gives you QRS complex. Okay. Another important thing here is, you might have questioned that P wave is because of atrial depolarization. So now, where is the wave of atrial repolarization? This atrial repolarization wave merges with your QRS. So you will not get different wave of atrial repolarization. Okay. Now, what is the duration of QRS complex? The duration is almost equal to P wave, 0.08 to 0.12 seconds maximum. Amplitude is 1.5 to 2 millivolt. Okay, 1.5 to 2 means, you can see here, 5 small square is equal to 0.5. So you may be having, sorry, 5 big square is equal to 0.5 millivolt. Okay, so you will be having around 3 or 4 big squares. Okay, not more than this 2 millivolt. Okay, what is the clinical significance here? This QRS complex in precordial leads, that is compared, that is more important as compared to QRS complex of your limb leads. Okay, now we will discuss one by one. You can see here, this is Q wave. It is a small negative deflection. Okay, amplitude that is less than zero point 0.2 millivolt. Okay, and duration is about 0.04 seconds. Try to remember all these amplitudes and durations. These values which I am writing here, this I have taken from the standard textbook. Your textbooks may have different values, so try to follow these values. Okay, now this beginning of Q wave that represents here, this one, mid portion of interventricular septum invasion. So suppose you can see here, this is SA node, then AV node, bundle branches. Okay, so when this mid portion of interventricular septum that is invased by this depolarization wave. Okay, so this may be slightly posteriorly. Here we have discussed two branches at the right and left bundle branch. One is slightly posteriorly. So this is you can say negative one. Okay, and most of the time it is not visible, so that is fine if you don't find Q wave. Okay, next is R wave. This one is R wave. This is prominent pointed positive wave, and that represents excitation of ventricles. Okay, depolarization of both the ventricles. Its amplitude will never be more than 2.5 millivolt, not more than. Okay, and amplitude of the R wave denotes functional activity of ventricle. Means if suppose the functional activity of ventricle is increased, like in ventricular hypertrophy, you have tall R wave. Okay, more than this 2 millivolt. Right? Then S wave, again negative wave here. Negative deflection after R wave, and that represents excitation of basal parts of the ventricle. Basal parts of ventricles when they are excited. I'll show you. You can see here. Suppose SA node, then AV node, bundle branches. So the excitation process moves like this. So when it is moving here, basal part, so the direction is opposite to the direction of electrical axis of heart. So this way, in this direction. So you'll be having negative wave. Okay. Now what is the duration of QRS complex? We have already discussed. That is about 0.08 to 0.12 second. It should never be more than 0.12 second. If it is more than 0.12 second, it denotes that block in this bundle branches. Okay, most of the cases in bundle branch block, this is prolonged. So what are the clinical significance? One, that is when you get deep Q wave more than 0.2 millivolt, and along with that you have other clinical features. It may be the suggestive sign of myocardial infarction. Myocardial infarction. Fine. If your R wave is tall, okay, it denotes ventricular hypertrophy. Ventricular hypertrophy. When you have low voltage QRS complex, that denotes, that is found in cases of hypothyroidism and pericardial effusion. Pericardial effusion. Okay, prolonged QRS complex, as I told you, it is always in case of bundle branch block. Bundle, right or left, bundle branch, we will discuss separately. Block, you have prolonged QRS complex. Okay, now we come to T wave. T wave is again positive wave. Here you can see, and this represents repolarization of ventricle. Ventricular repolarization. Very important thing here is depolarization as well as repolarization, both the waves are positive. Why? Because the direction of repolarization, or you can say the part which depolarizes last will repolarize first. Suppose you can see here, this is the pathway for depolarization, like this. Okay, pathway for repolarization is like this, in this direction. So your electrical axis, that is in the same direction. So you have T wave in the same direction of QRS complex. Okay. Now duration of T wave, that is 0.27 second. Okay, and amplitude, that is 0.3 millivolt. Okay, around 3.3, this two you can easily remember. Okay, and this is your T wave. Now what is the clinical significance of T wave? If you have flat T wave, it indicates insufficient insufficient oxygen supply to myocardium, oxygen supply to heart muscle, myocardium. Okay, sometimes in old age also you have this all find, you can find this flat T wave old age. Okay, if you find inverted T wave, you can see here, this is inverted T wave. It is suggestive of myocardial myocardial infarction or ischemia, infarction or ischemia. Okay, tall and peaked T wave, that is found in hyperkalemia when potassium level increases. Okay, then U wave, you can see here, after T wave you have this U wave, that is also positive wave, small and round, and that is because of repolarization of papillary muscles, repolarization of papillary muscles. The duration is 0.08 second, this one, and amplitude is 0.2 millivolt, and it is rarely seen normally, but it is prominent in cases of hypokalemia. Potassium level decreases. When potassium level decreases, you found U wave. So this is all about your different waves. Now we will discuss about segments and intervals. Very important thing here is, what is the difference between segment and interval? Segment, that is straight line connecting two waves, straight line between two waves. Okay, or you can say isoelectric line between two waves, no wave is included. An interval, that is one wave plus connecting straight line. Fine. Now, starting with this one, PR segment. This is, you can see here, this one. End of P wave and beginning of R wave. Normally we say R wave because Q wave is absent. So always, this is also said as PQ segment, but because Q wave is absent, we say it as PR interval. Okay, sorry, PR segment. Okay, this is isoelectric point between P wave and R wave, and the duration is 0.04 second, and this is the period of conduction pause at AV node. Okay, next segment, that is ST segment. This is one you can see here, at the end of S wave and beginning of T wave. This is also isoelectric period. Okay, and it measures the time interval from the end of ventricular depolarization and onset of ventricular repolarization. You can see here, depolarization of the ventricle has been completed and repolarization has not been started. This is the duration. Normal duration is 0.04 to 0.008 seconds. One or two small squares. Okay, as we know, one small square, in my last class I told you that one small square is equal to 0.04 second. Okay, and ST segment, this is elevated in patients with myocardial infarction. Okay, this is isoelectric line, but if it is elevated, I will show you elevation. You can see here, this is normal ST, but if it is like this here, this is found in myocardial infarction. Okay, then TP segment, you can see here, TP at the end of T wave and beginning of P wave. Okay, so this is the period that represents end of repolarization and beginning of new depolarization, and its duration, that is 0.2 second. 0.2 second means 5 small squares. Okay, you can see, because one small square is equal to 0.04 second multiplied by 5. Okay, that is the duration, and it is inversely related to heart rate. When heart rate increases, this duration decreases. Okay, and if there is atrioventricular dissociation, this segment is variable. Now we'll discuss about intervals. Interval, that is between two waves. Okay, so for starting with PP interval, that is the interval between onset of first P wave to onset of next P wave. So you will be having this P wave, QRS, T, all in between this interval, and this is equal to one cardiac cycle. This is equal to 0.8 second. Fine. Then very important interval comes now, that is PR interval. What is this PR interval? Try to remember here, it is the interval between onset of P wave to the onset of R wave or QRS complex. You can see here, sorry. This is PR interval, this one. Okay. Now, it represents depolarization of atria, that is atrial depolarization is equal to P wave. Atrial depolarization plus conduction time at AV node. Okay, it denotes these two things, atrial depolarization and AV conduction. Duration, very important things it comes here, that is duration. Try to remember the duration is 0.12 to 0.16 seconds. Okay, it should never be more than 0.2 seconds. When it is more than 0.2 seconds, it denotes conduction block. It indicates there is blockage in the conduction. And if it is less than 0.12 second, very low, less, okay, it denotes that impulses they arise from AV. Okay, now next is QT interval. You can see here, this is the QT interval, that is intervals between onset of Q wave, this one, to the end of T wave. So it includes QRS, ST segment and T wave. Okay, and the duration is 0.4 second. You all know QRS is 0.08, T wave 0.27 plus ST segment 0.08, 0.04 to 0.08. So it is 0.4 second. Okay, what is the clinical significance? QT interval is prolonged. This QT interval, this one is prolonged in ischemia, in ventricular conduction defect, and in hypocalcemia. Okay, ischemia, ventricular conduction defect and hypocalcemia. Okay, next is your ST interval. This is different from ST segment. ST segment is here, end of S wave to the beginning of T wave, and ST interval, that is interval between end of S wave to the end of T wave. This one, I think this is not shown in this diagram. I'll just show you ST interval. Just a minute. I'll show you. This is ST. I don't have ST. Here you can see this is ST interval. End of S wave to end of T wave. Okay. Normal duration, that is 0.32 seconds. Okay. And it corresponds with ventricular repolarization. Okay. Next is J point. What is this J point? It is the point at the end of S wave. Here you can see, and the beginning of ST segment. This is ST segment. Okay, this is J point. It coincides with end of depolarization and onset of the repolarization process of ventricle. And here this is the point of no electrical activity, means all the parts of the ventricles they are depolarized and therefore no current is flowing around the heart. Okay, and it is important to assess ST segment elevation or depression. This is the point by which you can come to know that whether this ST segment is elevated or depressed. So this is J point. Okay, so this is all about your waves and intervals and segments. Okay, this is again, you can make screenshot of this also, and this I have made a I have prepared a table in which you can find all the waves and intervals and segments. P wave, duration 0.1 second, amplitude 0.1 to 0.12 millivolt, QRS complex, duration 0.08 to 0.012 seconds, amplitude less than 2.5 millivolt, T wave, duration 0.27 second, amplitude 0.3 millivolt, U wave, duration 0.04 to zero 0.08 seconds, and amplitude is about 0.2 millivolt. Okay, then ST segment, duration 0.04 to zero 0.08 second, TP segment 0.2 seconds, about PP interval 0.6 to 1.2 seconds, or you can say equal to cardiac cycle 0.8 seconds. PR interval 0.12 to 0.16 seconds, QT interval 0.4 seconds, and ST interval 0.32 seconds. So this is all about today's topic. Again, if you wish to get soft copies of all my notes, it is available in the application VESALIUS. If you wish to get a hard copy of all my notes, that is also available. You can order Physiology notes, that is available on Flipkart and Amazon. You can also join us in a WhatsApp group, that is Number is 78638226668. Okay, and link for all that is given in the description box. Thank you so much. If you like my video, you can like it, you can share with all your friends, and subscribe our channel.